Hi everyone, my name is Girish, and in this video we will be building a chat with your PDF application. We will use Amazon Bedrock and use the Titan's embedding model as well as Anthropic's Cloudy model to build this application. We will also use technologies like RAG, which is Retrieval Augmented Generation, Langchain, Streamlit, Docker, S3, FAISS, Vector Index, etc. I'm super excited to build this application in a hands-on video like this, and I hope you like it. Let's take a look at a quick demo of what we will be building, and then we'll start doing the hands-on coding. So I have downloaded this particular PDF from a arthritis website, and I have created something called vector embedding, and which I'm storing in a S3 bucket. And in my client application, I want to query this PDF or chat with this PDF, asking it a question, and hopefully it can answer me with the context that I provide based on the vector embedding that I created. So let's go to my client application real quick, and I'm just doing some I'm downloading at this point. I'm downloading the index files and storing them in a temp folder, and then from there I'm loading it to our vector store. Now when I ask question to my large language model, I'm assuming that large language model has never seen this document before, or it could be a corporate document which is internal to your organization, and this is not available to the large language model when it was trained. So that's where the RAG comes into picture. Let's ask it a question. So let's say, what is a joint and how does it work? So based on the context provided, here's the answer. A joint is where two or more bones meet, etc., etc. And if I go back here, let's see, joint, how does it work? Let's see. So it got it from here and some other places in the document, and using this as a context. Let's say, ask another question. What are different types of arthritis? Okay, so based on the context provided, here are main types of arthritis, which is osteoarthritis, rheumatoid, etc. And this is again very contextual. Let's ask it a question which is out of context. For example, who won the World Series last year? Okay, so it says, unfortunately, I do not have enough context to answer this question, which is what we expected, because I want it to be very specific to the context that we have provided and use only the knowledge base that I am providing to it. So this is our application. So we will go back to our slides and see how I build it and what exactly we will be building. So what will we build? We build actually two applications. Imagine you have an admin site with which administrator have complete control, like which upload the PDF. This PDF document actually is getting split into various chunks. Why do we split into chunks? We will see it when we actually do the coding. But then each of these chunks get vectorized. Vectorization is nothing but getting numerical representation of the textual content. And then once it's vectorized, we store this embedding into FAISS vector store, which is basically we created the vector store locally and then upload it to S3 so it can be shared by the other Docker image. So once this is the admin side of the things where we will be splitting and storing the embedding, creating the embedding and storing them in a vector store. Now comes the user side of the application. When user asks a query like how we were asking, first thing it does is it converts that query into vector using the same Titan embedding model. Then it makes it, or it does a similarity search. what is similarity search? Is basically try to find documents which are very close in numerical space to what question that we asked. Once it finds those documents, it actually asks the LLM the same question and give them the document that we retrieved as a context. That's why it's called retrieval augmented. So we are augmenting our question to the LLM with the retrieved documents from a pre-indexed or pre-vectorized embedding stores content. So once we got we send or make the query to LLM, and then LLM response is returned, and we actually show it to the user as we have seen in the demo. So we'll be building these two applications. One is the admin side, one is the user side. I want to quickly touch base on the RAG. RAG is basically retrieval augmented generation. As we have seen, when the LLM was trained, whichever LLM you use, when it was trained, it did not have, let's say, the latest data, or it did not have your organization's contextual data. So in that case, we have two options. Number one is use RAG and keep providing it with the context when the user does a query, or fine-tune the LLM model to get the base LLM and then fine-tune it with your data set. Now, fine-tuning can be expensive, so it depends on the use case, but in most use cases, fine-tuning could be expensive. But if you are, let's say, using a lot of tokens for every request when we build the context, then and a lot of requests that you're making, in that case, it could be cost effective. You have to do the math. But in case of RAG, we actually, as we saw, we actually have built an index or vectorized embedding store. We get a similarity search to pull some similar documents and send those documents along with the user query. As it says, LLM uses knowledge base outside its training data source. So since LLM was trained at some date in the past, it does not have the latest data, or it does not have your corporate data. So we have to provide it with the knowledge base. So this is what we are doing in this case. So building admin side is super simple, and then we'll do the hands-on coding anyways. So we'll create an S3 bucket, we'll create requirements tags, create a Python application, build a Docker image, access the application from browser, upload the PDF, and we'll see the PDF gets processed. It gets converted into numerical vector embeddings, and this embedding is stored in S3. On the user side, again, we'll build a simple Python application and Dockerize it, and access the application from the browser, ask a question, and check the response. Again, my name is Girish, and I have been a cloud consultant for several years. And please do like, share, and subscribe to my YouTube channel. It helps me stay motivated to create more videos like this. With that, let's start building our application. Okay, so here I am in my Visual Studio Code, and this is where we'll be creating our application. So let me create a couple of directories. Let's call it admin and then also user, so that we can create our code in here. So let's go to admin. We'll create the admin application first. So first go to S3 bucket, and we can actually use the same bucket, or let's just create another bucket real quick, and let's call it YouTube demo Bedrock chat PDF. Make sure to copy this file or the name of the bucket, because we'll be needing it when we do the coding. And I'll keep all the defaults and just create the bucket. Hopefully the name is available, and let's see. So the name is available, so we are good. So I'm going to save this name somewhere. Let's just create a new file here, and I'll just save it right here. Okay, so let's start. We'll start with some of the libraries that we need for this particular demo. So what we'll do is we'll create a new file in here, requirements of text, and we need Streamlit. We'll also need PyPDF. We'll need Langchain. We will use FAISS CPU model, CPU and Boto3 for accessing our AWS. Let's quickly create a Docker file to build our Docker image. And the Docker file will build from Python 11, Python 3.11. And we will expose, for the admin side, let's expose port 8083 and let's say work directory. And what's the work directory? Let's make it /app, and we'll copy our requirements, requirements.txt to this location, and then run pip install -r requirements.txt. Then copy the rest of the files in the image, and then let's create the entry point. Entry point is Streamlit run, and what file will run? Let's make it admin.py, for example. And let's say what server port we run on, server.port. Let me just increase the font size a little bit. Server.port is, let's say 8083 we said, right? Okay, and then we can just do a server.address equals to 0, 0. Okay, so this will build our Docker image. Let's create a file called admin.py, and in this admin.py we'll write our code to do all the processing. So we'll import Boto3, import Streamlit as st, import OS. I'll also import something called UUID. So when we save the file, we'll save it locally with a unique ID. So I just want to test it real quick, so that let's do one thing. Let's just test it real quick whether our Docker image and everything is working, and then we'll come back and let's call it equals to, let's say, main. Okay, let's run the main function, and in the main function let's just run, let's just say in the main function what we can say is, let's say st.write, this is admin site for chat with PDF demo. Okay, let's just build this much and see if there are any errors. Hopefully there are no errors. Then let's just do this. So what I'm going to do, I'm going to build this, and let's docker build -f PDF reader, let's call it PDF, sorry, not -f, -t for tagging, -t PDF reader admin, and with everything. So it may take a little bit as it has to download. Actually I have downloaded most of the libraries, so it went pretty fast, but for you it might take some time. Now what I'm going to do, let's just run this, and I'm just going to say docker run -p 8083 in the interactive mode, which doesn't have to be interactive, but I'm just going to give interactive reader admin. Okay, I think that looks good. Let's try and see what happens. Okay, so it's running. Let's try to quickly access the application so that we you know that there is no error. Okay, so this is admin site for chat with PDF demo. So that's what I expected to see. Let's just build the rest of the application. Okay, so oops, sorry. Let's just do some housekeeping and download or import some of the libraries that we will need, and we will definitely need an S3 client. Let's say so S3 client. Let's call it S3 client. Ubuntu3.client. We'll say S3. We will also pass our bucket name where we want to store this as in an environment variable when we actually run the Docker container. So let's say get env, and let's call it a bucket name environment variable. Okay. Now let's say what else do we need? We need Bedrock related imports also. So what we'll do is we will import, since we are going to do the embeddings, we're going to import Bedrock embeddings from Langchain community. Langchain community dot embeddings import Bedrock embeddings. Okay. What else do we need? Now we will need a few more libraries from Langchain. Let's say here we need a text splitter, which we'll be using to split the text into chunks. So let's say from Langchain dot text splitter we'll import recursive character text splitter. Yeah, what is recursive character text splitter? So real quick, we want to, when we split the text, we don't want to split like this is one chunk, this is another chunk, this is another chunk. What we want to do is we want to split in such a way that this is the first chunk, then some part of the first chunk also goes in the second chunk, so that it doesn't lose the context from one chunk to the next chunk. And similarly, third chunk may have, let's say for example, some part of the second chunk towards the end as well. That's why we want a recursive character text splitter. Okay, what else do we need? We might need, we need the PDF loader. Let's say PDF loader, and then we'll say from Langchain community has something called document loaders, import by PDF loader. Okay, so that looks good, and then when we find some error we will import some more stuff. So okay, so let's see, we will start our upload functionality. So let's say we call it uploaded file equals to st has something called file uploader, and here we can say choose a file or some text, it's just a label, and then we can give file type, and here we are only accepting PDF type. Now if somebody has uploaded a PDF, what do? We need to process it. So if uploaded file is not none, then what should we do? Let's just process it. So what I'm going to do here is I'm going to generate a request ID just for just a unique ID just for traceability, and let's say let's write std write, so we see what request ID it is. And you don't have to print this, but this is just for my troubleshoot in case we have to troubleshoot anything. So with this request ID, I will generate a file name. I'll just say saved file name. So I want to give it a unique ID with the PDF extension like that. Then what we'll do? We'll open the file. with open saved file name, and mode is right. Let's call it W, and then what we'll do, w.write, and we'll say whatever file we uploaded, file dot get value, like that. So this will actually save the file locally, because why do I have to save it locally? Because PyPDF loader from Langchain right here, it actually takes the file name as a string, not actually the file content, file name, and then it does its processing. That's why we need to do it this way. Okay, so once the file is saved, what should we do? Let's just create an instance of loader, which is PyPDF loader with the saved file name. Okay, and let's just say pages equals to loader dot load. Oh, sorry, it should be pages equals to loader dot load and split. And let's just say we just write a quick how many pages are there. So let's say call it total pages in the PDF, which is length of the pages. Let's just do till here and create our Docker image and just test it real quick. I like to do frequent testing, so we are always sure that things are working up to that point. Let's see. Let me just refresh the page. Okay, so it's showing me the interface to upload the file. Let me just upload the same file. Let's see what happens. I'm going to upload this. What is arthritis? This documentation. Okay, so now it says UUID is not callable. Yes, that's correct. That's a mistake, and the UUID should actually be generated with a different syntax. So let's just create a simple definition of get unique ID, and the get unique ID will give me string of the UUID, UUID 4, let's say. Okay, return. So my request ID should actually be, let's replace it with this real quick. I'm going to build it again and run it. Refresh the page. Okay, dragging the file. All right, so basically I got okay, this is, so I have to see why it's giving me the functions instead of actually a request ID, but I saw that my PDF is loaded and it has total 17 pages, and if I see it here, well, actually it has, let me see if I have it downloaded. Yeah, it has 2 of 17, so it has 17 pages, so which is good. So let's see what's going on with the UUID. Request ID is get unique ID. Sorry, this is why it's showing me that way. But anyways, so let's keep moving forward. Okay, so now once we have these pages, or rather the PDF loaded, what do? We have to actually split the text from the PDF. So let's just say split text. Split text. Now what we do is let's create a helper method. Let's do splitted docs equals to split text. What do we pass it? We pass it pages. Now let's just say we want to have chunks of size 1,000 characters and with 200 overlaps. As I was explaining earlier, we need overlap so that next chunk doesn't lose the context of the previous chunk. So let's do it this way, and then we'll just do this st.write just splitted doc length, and let's do length of the, because there are 17 pages and they probably have more than 1,000 characters on each page, so we should see number of split on the should be more than what the actual number of pages were. Let's just print couple of splits. Let's see st.write. I'm just going to do this a little bit of separator so that I can see what's on the pages. st.write, and what do we want to write here? We want to write our splitted docs. Let's just print doc 0 and doc 1. That's for fun. Okay, you don't have to do this all, but it's just to test that splitting is working. So now we have to create this function called split text. Let's just define it here. And in the split text function, split text, what we will do, we will create recursive character text splitter. So let's see what do we need. What are we getting here? We are getting pages. We are also getting our chunk size, and we are getting something called chunk overlap. Once again, you have to test what chunk size and what chunk overlap gives the best results, and depending upon your needs. But for me, I'm just testing with 1000 as chunk size and 200 as chunk overlap. So let's create this text splitter. What do we create? We're creating recursive character text splitter with chunk size equals to chunk size and chunk overlap equals to chunk overlap. Okay. Then what we do is we use this text splitters instance to split our documents. Split documents. These are my pages. Okay. Sorry. And the splitted pages we return the docs. So let's just do here. Split the pages or text from the pages into chunks. So each of these docs will actually be one chunk. So we will get some number of chunks, which is definitely more than 17 if there are more than 1000 characters per page. Let's run it till here and see what we have, what happens. Okay, so let's go back to our demo and refresh the page. Let's drag the file. Okay, as we can see that we're getting total 17 pages, but we got split document length is 42. That means it has divided our 17 pages into 42 different text different chunks. Well, actually I just put 0 in both the places, so that's why it's showing 0, but we could have probably just checked it here with what's the second split. We can just do it when we do the next test. Okay. All right, now we got a splitted text. What do we do next? So after the split text, we have to create the vector store. We are going to use FAISS as our vector store. So let's say, just give it a little note that, hey, writing the or creating the vector store. Okay, then let's just create a function called create vector store, and we'll pass the request ID and the documents or the splitted documents that we just got. So we'll just call it splitted docs. Let this function return a boolean, that's a result. And if result is good, what we'll do, we'll say st dot write, let's just say hooray, PDF processed successfully. Else, okay, let's see, st dot write error, please check logs. Okay, so here we'll be creating a vector store, and let's define this function. I'm just going to copy the whole thing from here and then vector store. Okay, I don't know if we imported FAISS when we imported. Let's see. So no, we did not. So let's import that now. And this comes from Langchain community dot vector stores import FAISS. Okay. So let's create our vector store. Let's see. So here we have, let's call it vector store FAISS equals to, let's say FAISS dot from, it has a method called from documents. What does it take? It takes documents, which is what we passed, or actually in our case we passed splitter docs, so let's just call it documents. And it also takes embedding, which we did not create yet. So let's say Bedrock embeddings. Okay, so let's create the Bedrock embeddings real quick. And Bedrock embedding, we imported it, right, but we haven't used it. So let's just create it right here and just say Bedrock embedding. Actually, we have to create the client also. So let's just create the client. Let's just first create the client, Bedrock client equals to boto3 dot client with the service name as Bedrock runtime. Okay, now Bedrock embedding is actually Bedrock embeddings, and then you have to pass the model ID. And please check my previous demo on how to find any of the model IDs, but let me just quickly show you. If you go to your console in Amazon Bedrock, if you go here and look at all the base models, for example, and here if you see Titan, and if you go to Titan text embedding, for example, if you scroll further down, you will see some examples and also the model ID. So we are going to use this model ID, embed text 1 v1. Let's just copy it from here. And it needs also client as our Bedrock client. Okay, so Bedrock embeddings right here, embeddings, let's call it embeddings. Okay, so where am I? So I got the vector store FAISS from documents, what we are passing, and using this embedding. So it will split the text. It has already split the text. Now for each of our text, it will create numerical representation of that text, and using Amazon's Titan embedding model. Okay, so once we have this, let's see where do we want to save this. So I'm just going to give it a, let's say file path. This is a local path. File path equals to that's where I was, that's why I passed that request ID, because I want to, let's say if you want to upload some more PDF, then we want to save it a different request or different location, so it will be unique every time. Let's call it folder. Folder path is, for example, I'll just say /temp, and let's go, we'll generate the index and save it locally. So it's just vector store FAISS dot save local, index name equals to, actually let's call it file name. It's not a file path, sorry, file name. Index name is my file name, and the folder is, folder path is my folder path. So at the end of this method, if it's successfully run, it will save my request ID.bin, and it will save that or create that folder and save the index related files into that particular folder in the temp file. Okay, so it saved it locally now, but we want to actually upload it to S3. So let's just do this, upload to S3, because if it saved it locally, it will only be on this Docker container. I want it to create once and use it on the multiple client containers if you have more than one. So let's upload this, and then we'll see or verify this in S3. So S3 client, it has upload file function, which takes a few parameters. First name is file name, which is my folder path plus file name plus, it creates FAISS index create two different kind of files. One, it ends with .faiss and the other one ends with .pkl. So we'll upload both the files. So this is the file I'm trying to upload. Where I'm uploading it, so it takes something called bucket, which is bucket name. We already defined that. And what is the key to this file in the S3 bucket? So let's just call it my FAISS dot FAISS. Okay, so this is the first file. I'll just copy this, and this will do the second file, which is actually nothing but pkl file, and just call it pkl. And if there is no error, let's just return true from here, because we have a logic to display success message. So let's just call it main method. Okay, cool. So we are, from the document that we splitted, we are actually using Bedrock embedding, or sorry, Titan embedding model from Bedrock to create the vector index. We save it locally first, and once it's saved, we actually upload these two files to our S3 bucket. And if everything goes well, we should be able to see this uploaded to S3. Okay, so let's do one thing. So now let's just build the Docker image first. Now this time I have to pass an environment variable. As I said, bucket name is coming as an environment variable. We also need this Docker to be able to access our S3 bucket. But how do we do that? So what I'm going to do, I'm going to mount my AWS credential into the temp directory of the Docker image, so that I don't have to copy all my access keys, etc. And it should be able to use that to run the application or access the S3 bucket. So what I'm going to do this time, I'm going to start it a little differently, and let's just do it here. So instead of just running like this, I'm going to pass in some more parameters. For example, -e bucket name, and bucket name, we actually created a new bucket, which is this bucket. Bucket name is this. Okay, and we also going to mount my AWS folder, which has my credentials, to root or AWS. So my Python file from there, oh sorry, my Boto3 can actually find the credential which has enough permission to use the S3 bucket. Okay, rest is fine. Let's run it, see what happens. Okay, so let's go to our application and then refresh the page. Okay, unknown service, Bedrock, runtime, service names are, maybe I did a typo. Let me see. Let's see what happened here. So it's right here. Boto3 client, service name, Bedrock dash runtime. Okay, let's try to fix it. In the admin file, let's go to where I'm creating this. Bedrock client, service name. Oh, sorry, it took the whole thing as a string. It should not be like that. It should be like this. Okay, so let's just rebuild the image real quick. It's pretty fast because it only takes time when you build it first time. After that, it's super fast. Okay, so let's try to refresh the screen again and see what happens. Okay, so far so good. Let's check the bucket real quick that we created. It should not have anything at this point. Yep. So let's go back to my application and try to upload the PDF. Okay. So now it sees this is the first chunk. This is the second chunk. So or first page and the second page, and now it says here is creating the vector store, which takes a few seconds. It's not that big of a file. So. Okay, and it says, hooray, PDF process successfully, which means our index was created and must have gotten uploaded to the S3 bucket. Let's just refresh it. Yes, I have my FAISS and PKL files uploaded in S3 successfully. So now we can build our user web application. Let's do that. Okay, so let's build the user application and let's go to the folder user. Let me just open another bash terminal right here. cd user. I'm going to copy paste some code and some of the files so that this video is getting really long already. So I'm in the user. So what I'm going to do, I'm going to copy the requirements as well as Docker file, so we can just quickly change it. Okay, let's go to user, and in the user requirements, I don't need the PyPDF because I don't need to read the PDF anymore. So I'm going to remove this, the rest of the stuff we need. And in the Docker file, I am going to run it on a different port. And let's call this, everything else looks good. Oh, I'll call it, let's say just app.py. Let's make it run on 84. Okay, so create a new file called app.py, and I'm going to copy some stuff from the admin, and let's see. Okay, let's see this. Oh, let me just copy the entire admin and then we'll remove what we don't need. Okay, so I'm going to just say, let's say, just do the st dot, let's call it header. And this is, oh sorry, let's say client side for chat with PDF demo using, let's call it using Bedrock, RAG, etc. Okay, so this is what I want to just quickly test my my image building and other things. So let's just do this, and I'm going to remove other things as we come across, but right now I just want to test my function real quick, and or sorry, my image real quick, and then we'll see. So let's just build this and then we'll run it. So okay, so to build this application, let's stay here and then let's do docker build -t. Let's call it, what do you want to call it? Let's call it PDF reader or read client application, since it's a client application. Okay, sorry, I did a mistake. So let's say docker build, and I have to give the current directory. Okay, so it built the image. Then let's run it and then we'll see what happens. So let's just run it docker. Actually, let me just copy that same command that we used to run admin. So I'm going to just run it like this. PDF. Actually, did I put reader or read? Let me see real quick. Oh, I want to make a reader client. Let's just create another image. Okay, let's run it. So okay, that's fine, we'll upgrade it later, but let's run this application real quick and see if it's loading for us. Localhost 8084, oops, sorry, localhost 8084, like that. Okay, so it's actually loading the application just fine. So let's just build the rest of it. Okay, so let me go to my app.py, and then this is where we will be starting to build our application. So first thing first is we have to load the index. Load index. Now where are we going to load the index from? We are going to load the index from S3. So let's call this load index and define a function called load index. So we'll use the S3 client. I think we already created S3 client since we copy pasted. So let's just do this S3 client dot download file. And what do you want to download? It has to take some parameters. Let's say this is a bucket name. Then what's the key? The key is actually how we store it in here. So this is the key. This is a key for the first file, and then there will be key for the second file. So I'm just going to give it a key like this. And what is the local file name? So local file name is, let's just define a file path or folder path somewhere here. Let's see. Folder path equals to, since we are going to, let's download it in the temp directory. I'm just going to say /tmp. Okay, so that's my folder path, and let's go back here, and this is my folder path. And what are we downloading here? My FAISS file. Let's download the second file also, which is nothing but the pkl file. Okay, so we downloaded these two files in the folder path. Let's do one thing, let's just show this real quick to see whether it's downloaded successfully or not. So what I'm going to do is, after we download or load the index, what I'm going to do is let's just list the directory using the os.list dir and folder path. Okay, and let's just write it files and directory in, okay, let's do it this way, in the folder path. Okay, and we'll just list all the directories and the files in that st.write dir list. Okay, so if it's loaded successfully in our temp folder, we should see the list of the files from there. Let's just quickly build it and see. Once again, I want to test at every step so that it doesn't come as a surprise if something is not working later. All right, let's do this. Let's go back here, refresh the page, and once the page is refreshed, oh yeah, so my files and these files are downloaded and they are stored in the temp folder. Great. Now we are going to create our index, or like FAISS index loaded from these files, and then we'll be able to query the index. So let's do one thing. From here, let's just do create the index, or let's say create index, or it's not really index, it's actually store, but let's just call it index. Okay, so we'll call it FAISS index dot what do I do? Earlier we did save local, now we're going to do load local, load from local, load local. What are we loading? So index name is my underscore FAISS. Then what's the folder path? Folder path is the folder path that we gave earlier. Now what are the embeddings we are going to use? Because we have to create the vector representation of this data as well as the user's query data. So embeddings is embeddings are Bedrock embeddings. Not this. We actually created Bedrock embeddings, this one, yeah. And let's see what happens. Okay, so it created the index, and then we can actually, after this, we can just say st.write. Let's say index is ready. Okay. While this thing is doing it, what we can do, we can also test it real quick actually. Let's build the image and run it. Okay, refresh the page. Okay, so it's a deserialization relies loading a pickle file, so and so. So okay, what we're going to do is we are going to, I mean, it's probably not a good idea to do it in the production, but we have to allow deserialization in this case. So what I'm going to do, I pass another parameter called deserialization equals to true, like that. Okay, so let's refresh this and see. No, actually we have to build it, sorry. You could do it without Docker also. I just choose to do it in Docker. It's easier that way. So so that when you want to upload it to ECR or even Google, it's like already available for you. Okay, so now what's the issue? Load local, it says index name dot FAISS. Do I not have an index name? I am passing the index name. So let's see what's the issue now. Constant character at this field could not open file for reading. Okay. Okay, I think I figured the problem. It's the typo, I think, right here. Let's just quickly do this testing. Okay, look, go back to this and let's see what happens. Okay, now it's the index is ready, so we are good. Let's just build our rest of the interface and the query the index and get the response. Okay, so what we're going to do now is index is ready. So what we are going to do is we are going to create a field where let's say if I'm not going to create a button on the, and let's call it ask question. If that button is clicked, what do we do? With st.spinner, we say, okay, or we just call this a querying querying, please wait. So we'll get a LLM. Let's call it to get LLM. We're going to create a method, and then what we're going to do once we have the LLM, we're going to get the response. So get response. So how do we create this LLM? Let's see. Let's create a method called getLLM, reusable method. So let's call it define getLLM. Since we are using cloud model, so we're going to say LLM equals to Bedrock. I think I have the Bedrock imported. If not, we'll have to import it. So let's see. Let's import the Bedrock. We import the Bedrock from, let's see right here, from Langchain.l, I think dot LLMs dot Bedrock import Bedrock. Okay, like that. So let's do this. We imported it and go back. Let's go back to our LLM. So we call it Bedrock. And what do we actually, which LLM are we going to load? We are going to load the Cloud LLM, Cloudy or Cloud. So we have to pass the model ID, which is actually Anthropic. Let me just copy it from the Bedrock website right here. If I go back to base models, and I think this is the one. So if you scroll down, this is the model we are going to use. So this is the model ID. Now what is my client? Client is Bedrock client. We already have an instance of this, and then there's another thing called model KW args, and in this we will actually limit our model to generate maximum tokens, like 512 or something, max tokens to sample. Let's call it, let's keep it 512. So I'm actually creating a Anthropic, I'm getting an instance of Anthropic model, and we will be using Anthropic model to generate our user's response. So once this is done, let's just return the LLM. Okay, so we got the LLM from here. Now we get the response. How do we get the response? So let's create a reusable method again for getting the response. Get response. Okay. So okay, we will actually be creating a prompt. So I'm going to copy some code from, so I don't have to type it, and I'll just explain this here. So okay, so we have to import a few more things. Let's just do that first, and then what I'm going to do is we have to import prompts and the chain. Now what is the prompt and chain? Let's see, let's talk about that real quick. So prompt is basically how you send information to an LLM for querying something, and this is where we will be sending our user question as well as our context. And chain is basically how do we want to change this this whole process. So basically we are saying, hey, use this user query, use this embedding model to embed or create the vector for the user query, do a similarity search, and then use all the documents retrieved using similarity search as a context to the LLM. So for that we'll use something called RetrievalQA, which is question and answer. And let's go back here. So LLM is LLM. I have to pass the LLM to this response method. We'll pass it from there. And then what is the vector store here? Let's see real quick. And I'm going to say, okay, actually we have created the vector store. If you see right here, this is my, let me just make the method here, it's easier that way. So let's just say get response, and I pass it LLM. We'll also pass it the vector store, which is nothing but the FAISS index right there, which is right there. And what is my user's question? So actually we did not bring the question, so let's just say, sorry, we'll create a text field, st.text input, and then let's ask please ask your question, for example, and then we'll pass this question also as the user query to the response, and the response will actually give us some text back, and then we'll just write that text back to the screen. Okay, all right, let's go back here. What did I miss here? Oh, I missed the, okay, so what we are doing here, once our index is ready, we are showing a text input for where the user can answer the user can ask the question. We'll use that question to get the contextual documents from using similarity search from the index that we built, and then we'll use that question as well as the context to query the large language model, and whatever response we get, we are going to display it here. Let's say st.success. Let's just call it done. Once our LLM is able to answer properly, let's go to get response here. So here is the prompt template. So all the models take different kind of prompt templates, so you have to check the model's documentation. In this case, for Claude, we are actually sending human. Human is saying please use the given context only to provide concise answer. If you do not know the answer, just say I don't know. Don't try to make up the answer. Like how we asked it a question, who won the World Series, it could not answer. So here I'm passing the context, and my question is, actually I can close it, doesn't really matter, but yeah, my question is here and assistant is here. In the prompt template, I'm using this prompt template and using these input variables to provide them with the context. Now retrieval, so this is called vector store, so I have to get the vector store as well as the question. Okay, so now using the prompt template, I'm using something called RetrievalQA, which is a chain, and this chain actually is as I said, it will do the similarity search to our embedding or vector store, and it will find 5 relevant documents or 5 relevant text chunks which we will be using to send to the actual large language model. Once it has the result, we'll return the result and we'll display it to the user. All right, let's go build real quick and run the Docker image. Okay, let's go to our screen and let's refresh this. Okay, so I'm able to see the index is ready. Now I can ask my question. So let's ask a question. When should I see a doctor about arthritis? Let's see what it says. It's querying. Okay, so based on the information or context we provided, here are some of the things, and it's totally relevant to the document that we index. Let's call it, let's ask another question. Who won the Cricket World Cup in 2023? Let's see what it says. Okay, so as expected, it does not have enough context because we are only providing context from the arthritis PDF that we indexed, which we create an index for. So that is it. So we were able to build our admin site as well as our user site in this particular video. I hope you really liked it, and please like, share and subscribe to my channel. It helps me stay motivated to create more content like this. And again, if you have any cloud project coming up, you can reach out to me. If you need any consulting help, you can reach out to me at girish@jajusoft.com. Thank you so much. I hope it was helpful. I hope it will be helpful for some of your projects. And please like, share and subscribe to my YouTube channel. Thank you so much. I will see you in the next video.